Okay, welcome back. We are through with cross tabulations. There are a lot of things there, but our emphasis on chi-square, test of independence, which is a test of association between two variables. And you notice the data. That's why I didn't ask us to use B total. The data has to be count data, frequency data. That's why we use B1 to B6 for that chi-square. That's why we didn't use B total is when we will be looking at correlation, that is tomorrow. Correlation, regression, analysis. So we have two more things to do today. We look at, after cross-tab, we look at compare means, and then we look at different ways to create charts, bar chart, pie chart, and the rest. Then in the final part, we look at factor analysis, and then we call it a day. Then tomorrow, we start with the third module, which will now be part of statistical inference. So let's, since we are okay with this, we don't need both. Before we look at compare means, it's part of inferential statistics, because a statistics is divided into two. You have descriptive or exploratory, and then we now have inferential statistics. Then in inferential statistics, we call it statistical inference. It's a course in mathematics. You have estimation and hypothesis testing. So in the estimation, you have point estimation and interval estimation. And theoretically, your point estimation will satisfy 4 criteria. 1, it has to be unbiased. 2, it has to be efficient. 3, it has to be sufficient. 4, it has to be consistent. Then in interval estimation, we now talk of small mean, large mean, proportions, variance. So we are going to look at all this, regression, the correlation analysis tomorrow. So but before we go further, let's pause a moment and look at, okay, let's go to chart. Okay, let's go to compare means. And what does this compare means tell us? As far as I'm concerned, I'm not too comfortable of, because this comparing means is all of them are part of inferential statistics we are going to do tomorrow. So let's look at factor analysis first before we now look at chart. Just pardon me to deviate a little bit. So I have a work. I have a work from my student that did. This is very sensitive. So factor analysis is used when, so I want us to see the student questionnaire. So we just look at one example. and then how factor analysis grouped the 15 factors into 4. This is a questionnaire that students want to ask. Do you think that community development association in your community has contributed the following in developing your community? So we have road repair, security, water supply, healthcare, road construction, environmental sanitation, conflict resolution, drainage system, environmental beatification, amusement activities, educational tutorials, loans or credit schemes, support in social events, and electricity. These are the factors that it's an estate in Lekki. The student is living, one of us is residing there with the parents. So we want to know, they've now formed an association. It's a community development. And this questionnaire is for those living there to know if these factors were the things that motivated them to creating or joining that association. So we have how many factors there? 15, maybe 16. So because why I'm still saying this is that this is exploratory factor analysis, which is part of descriptive statistics. Then when you are running your SCM, you have the one we call confirmatory data analysis, confirmatory factor analysis. So this is just the same descriptive statistics. So I will provide the data. So there are a lot of things there. The student did 3 factor analysis. This is another factors. Do you think that the following challenges have affected the way the Bashirun town is being developed? This is another list of factors. So why I'm saying that this is a typical student project that you can, a student will come around, especially those in social sciences. You now have to go to literature and look for factors. So when the student look for factors, maybe 15 or 16, the student can now apply factor analysis, just a small project, and they explain it, and that is the project. So let's go back to the data. So this is the data for the student. We are working with B1 to B14, which is the 14 variables. So what factor analysis does is to cluster these 14 variables into the major factors. It can be, if you look at, I did a paper on ICT adoption. So we apply factor analysis to define, to cluster the about 16 factors we found that affect ICT into like 4. So automatically, you have the one that may be environmental factors, technological factors, social factors. Okay? Okay, let me use an example. So after that, I will now give you the, so you go to analyze, if you want to run factor analysis. So you go to dimension reduction. And then you click factors. Then I select A1, B1 to B14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are the 14 factors. So I go to this place And this is the most important. In factor analysis, it's called the KMO test. KMO and Bartlett's test of sphericity. It has a benchmark. It's like Kronberg alpha or Gottman. We say either Kronberg alpha or Gottman. So we can perform it in factor 1 to 6. Okay, let's go back. In the data we have, that is 1 to 6, 1 to B6. So go to analyze, dimension reduction, factor. You select B1 to B6 to the factor list. Dimension reduction, factor, analyze, dimension reduction, factor. Then select B1 to B6. So I'm not, this is one I'm doing. So, yes, the variables is B1 to B6 only. Yes. Then click descriptive. And then click the KMO and Bartlett test. I said we should use our data B1 to B6 only. You go to descriptive and click KMO, test of sphericity. Okay, then continue. Okay, let me assume this. I don't want to go further. I just want to see the classification. Okay. The KMO test has to be at least 0.7. And the Bartlett's test of specificity said that the model is significant with p-value 0. The model is significant. No, I'm using I use it. This is my own student data, not what you did. Okay, let me see the factor. Wow, this is nice. You see what it does? It clustered that 6 into 2, into 3. Look at the last table. You know why I don't want to use this? I know that one way. These have many variables. Okay, I will repeat it so that we look at it. Okay. So I was, because the variable we are looking at is 6. So I have not done it before. I was thinking because there are some cases it will cluster the variables into 1 because the thing requires variable to be much, like 15, 16, 17. So this is very important for student projects. You can give them a research topic, maybe divided into 2-3 sections. One will have like 12 questions. Another one will have 14 questions. Another one will have 16 questions, which is the same Likert scale. Then when they get the data, they will use factor analysis to divide it into 4. So what factor analysis does is, this is the last table for my students. This is the major thing there. It has grouped these 14 factors into 4 major groups. So there are a lot of ways to create these 4 major groups now. You can be an environmental factors or security factors. So I don't. Okay, let me know if I could see the analysis there. Okay, let me look at this our own. So don't mind me. So let me close the student on and let's do ours. But when the KMO is less than 0.70, there is issue. The result may not pass the scientific test of peer review, because that is to show that the responses are random. Because most of statistical tools or theories are based on independence and random. Events are independent and then they are random. So my own clustered it into 4. So you have C1 to D1 to this. So but let looks, as you have said, let me look at our own here. Dimension reduction factor. So I'll be B1 to what? B6. So what is this table telling us? This. Okay. I want to look at, just give me time. So I want to show you a practical example where factor analysis was used. So we use factor analysis here for, we have, I think, 15 factors. Okay. This is primary school. You see now, I didn't present the data the way SPSS would have presented it. See, I removed that valid percentile. Have you seen it? So there is no need for valid percentile. Then factors, factor analysis. You see our own, the commonalities. There's something I want to show us, the components. Yes, the interpretation. This is the most important. See, it's grouped them into 5. So number 1 factor is the assistant or support factors. So what it means is that you go back and then choose the ones that have the same attributes. That's what factor analysis does. You can now go on how to make decision from here, from these 5. 1, it's grouped it into 5 groups. These 5 groups are the 5 factors that summarize all the all the variables. So this is factor one. Like for in this case now, you have, these are the major factors that affect ICT. The assistant or support, the availability. Availability is whether you have internet. That is what this thing means now. All the questions that relate to availability that you don't know, that is in the question, the factor analysis will group them together. All the questions that need to support services in ICT, it will group them together. So at the end of the day, you have 5 major factors. And these are what that's usually, so these are the contributions I am making to the theoretical framework. So this can be used, but this has been gradually replaced with confirmatory factor analysis, which is a structural equation model. For here now, okay. And you got the value from, look at it. What I mean is that it grouped the 6 there. Textbook, laboratory, furniture, curriculum, instruction into 3 major groups. Okay. These values I put on the table. And that's why I say for this one particularly, I can choose, I can remove all that are negative. I can remove textbook. I can remove, that is for these 2 now. You understand? Obviously, this number 1 will be textbook, 0.704. It's 3 variables at the end. It has grouped it into 3 major variables. What happened? Oh, okay. Okay, the light is off. No, it's still. When there is fluctuation, the light will off. When there is current spike. So what we often do is there is no one measure. What, like that first case? Okay, you are with your system. Let me. This is coming up. I think when there is, maybe I touched it, so the thing off and it drained. Yes, I just on it. This was not on before. So apart from factor analysis, you have correspondence analysis. All of them, the data must be discrete values. Yeah. Man, it's advanced. It's not part of the. No, that one is, if you want to do it, you use that one they call SPSS, EMOS. That's what we use now over there for analysis. It's expensive, though. It's not like free like this one you can easily get. Okay, I'm coming, man. Let me on. I think when there is spike in current, the light off. Okay, thank you. It should be working. Okay. Okay. So, yeah, Malama, you're asking questions. What, what that amount does is that it will, that one is confirmatory factor analysis. This one will just explore, but that one will confirm these are the factors that are responsible. So that one is far higher than this. Okay, it's not part of the model. But me, I thought even this factor was not part of what we have to do. But I thought that because most of undergraduate students are in that area, we need to know about it. Okay. So apart from that, there you can Google and this HAYS, HPSS HAYS, HAYS, is used for mediation and moderation analysis. You have different models. Model 1 for mediation, 4 moderation. So you install it and then you'll be using it on my system. But it's not part of what we do. So when you install it, I'm not good at SPSS HAYS, especially for those in social science. So let me show you the thing. When you want to do regression, you see, you have this, that is the process. This is very key. That's what I use for the person I helped for his PhD analysis. This can be used for moderation and mediation analysis, or moderated, when you see some papers, or moderated, or we call it hierarchical regression analysis, where you have mediation, moderation analysis. So it's not in your SPSS, but you have to download it, and they call it macros, SPSS macros. So you use it, when you install it, you can run this. You download book written by HAYS, or you go to his website. Number one there is mediation. The 2 there is moderation analysis. So he has a lot of model, up to 99, you can imagine. So you can have covariance where you control the effect of some variables. So at the end of the day, you have some fine models that you can use. So let's go to compare means. This is just you have SPSS HAYS, HAYEX, S for soccer. So download it, install it with your SPSS, start working. You use it for moderation, mediation analysis. Let me show you how the model will look like. I'm coming, man. I'm coming. We are still going back there. Okay, is it on the student project? Sometimes I forgot. Okay. Personality traits, discussion. Okay. Let me check. No. Can't be here. Please, you can Google mediation and moderation analysis. Google it, please. Because all these tools are used by, especially those in social science. Yes, it's not there. You have to install it. Yes, something like this. You might have seen, this is a moderation analysis. You have that one here is what we call the interacting verb. This is the X, this is single moderation, where you have one dependent and one. Then the one I like so much is mediation. Mediation have something like this. Have you seen model like this? It's generally in psychology, you know, when a variable is mediated. So why these tools? Because of student projects. I have a lot of tools to work with when you are handling student projects. Then you can control the effect of the variable using covariates. When you do that, you have a very complex model like this. This is the effect of the covariate. So this is just an introductory ACM. The ACM will now give you all the data together. So I think before I go further, she requested that I think there is some question from factor analysis. Yes, ma'am. Yes, correct. Yes, you know why I didn't want to do that is that there are a lot of, you have variance. Check it, there are a lot of options. Variance, you have so why we are doing this is that I want to bring people's awareness there so that you can play around with the data. You understand? So if you are doing so, maybe you rotate it first with, you know, that's how I write papers. Sometimes I will say, I don't want to write only factor analysis. I will use that rotation. I will have 3 results. I will compare. It became a comparative studies. Okay. So, and let me stay here. One of the papers, one of the research that usually got accepted is like a comparative study. When you want to compare your result with a previously one. But when you are comparing, the paper that you are comparing must be from a high impact journal or a journal that is okay. If you want to extend, especially my colleagues in mathematics, maybe you want to extend the model and the journal is on a predatory journal, you're extending it and you are sending it to a CVR, it will be rejection before even, because they will have to say, they don't have the belief that the result was adequately peer reviewed. You understand? So one of the things people, that's why in social sciences, they normally like comparative studies. You compare your work with someone else, and then based on your data, and then you report the results the way it is. I compare. This is where my own, this is how, to the extent my work compared with that one. Then before that, we now begin to have some insights, because our research is to, you know, for people to have insight on things that was not existent before or things that we have neglected. Okay, when you have insight from the work, so most people begin to, you know, write papers in that aspect. Okay. Secondly, if you are, you know, working with data always, you have to be current on the where is the research going in that aspect, in that area. Okay, so that you won't be working on something people have done 1922. That's what you are working. Nobody will be interested. So you see a recent paper published in a journal, and you feel, just the best way to even learn, especially for those in mathematics that work with model, is that when you see what somebody published recently, you say, I can add more variables to that. When you add more variables, or this is what the kind of data these people collected. They didn't add this aspect They didn't add this aspect. They didn't add this aspect. So me, I now construct a questionnaire, adding those aspects, and then I will analyze it, and it will get published. That is the way. You know, I'm surprised when some people say, I don't see what to write. For me, I don't have time. Because if I'm continue to write, I don't know. So what to write is there. If I look at a paper, 4 papers can come out of it. Maybe because of mathematics, you know. Yes. And all those things have to do with data. For example, this is very important. I don't know whether it's applicable here. In CU, you don't have PhD or master's without papers. Then you now ask yourself, how will I get 2 papers and 1 conference to graduate as PhD? Fine. Like this paper, this analysis I showed you now, I did. What I did, the man took data from Ekiti, from 6 states in Nigeria. So one of the conference paper that I submitted, work with the master. Okay, let's limit some part of it to Lagos alone. It's the same data. The first thing you have to do, especially for those in maybe Greek, is to do a systematic review. You know, systematic review generates data. This is what is available in that area. Okay? What systematic review sometimes revealed is that there is something that should have been added to this questionnaire that people have been neglecting for years. You review the instrument of data collection they use. And I find out that, okay, based on the gap that I want to bridge in the literature, okay, this has to be there. It becomes a contribution. Sometimes the questionnaire you design becomes a contribution to knowledge. Why? If you design something someone else have not designed before, yes, it's contribution. Somebody can adapt. Somebody can adopt or adapt your questionnaire and tell him. And then I can't remember how many times some people email me from Taiwan, from US, say that, sir, I want to use your questionnaire. I say, use bet, cite me. I have a lot of citation. They just use your questionnaire. There is nothing wrong, you know, a questionnaire in US. You use it, apply it to our data here, and get data different from that one. So in that case, you are adopting. But when you are making some modification, you can adapt because you have to add some 1 or 2 things. Okay? So there are a lot of things to do with data. If you are good in data analysis, I don't think writing paper will be a problem. None. Even now, I don't like writing in data analysis. I like writing in core statistics, where I involve, but my area is mathematical statistics, application of mathematics in. So you can see me applying differential equations in normal distribution. Because I know I can easily get paper using data analysis. So, because most times, those of them will be laughing. Hilary, this is your paper. We could not see one equation. You can't see one equation. You know, it's data. Sometimes I try to balance it. You know, you can't see one table. Can't see everything will be solved. So that is it. So you have your data. You can write as many papers as possible. Okay. You can tell the students, okay, like that student project, the supervisor say, since we did a nice work, it will be published. Okay, so it counts for the student as projects, it counts for you as paper. But make sure the student name is included. The paper is being published. That is ethics. So that I won't hijack. So let's compare 2 means from B1 and B2. Most times, this is my... So this is when we have to compare 2 means. It can be 3 means. It can be 4 means. It can be 5 means, it can be 6 means. So I'm trying to know if I have data that we can apply shard. Because I don't think this one will give us what we want when we'll be doing bar shard, partial, and the rest. So this one, we want to compare the means. It's part of what we have in the module, but most times I try to deviate a little bit so that I drive it home. Okay, yeah, okay. Yes. No, just no B1 and B2, because those one are variables. The other one are yes. Leave the demographic variables. The demographic variables are obviously the independent variable. If we are running regression by tomorrow, we'll use the B total as the dependent, and then we use the variables, and then we interpret. So I will try to see if we could I bring data that has to deal with binary logistic regression, so that we'll talk of what to call odd ratio. So maybe by tomorrow, the one I brought, so I will. No, the B total will be yes. So that's why I have that, because it's continuous. Yes, regression demands that the dependent variable must be continuous. So if it's not continuous, you can call it ordinary regression, but if it's ordinary least square, the dependent variable must be continuous. So the rest of the things we have to do now is to look at the chart. But I don't know if this data can sufficient enough for us to work at it. We're a little bit faster today. Okay, you see this beam now. What is it telling us? That, what there's something called mean ranking is from this area, you see it. That is, textbook is 3.5, laboratory is 3.4. That is textbook, the first one, the former has the higher mean than the other one. No, you can do B1 to B6. Okay? So why are we comparing means? As I said, it depends on the variable you are working. So let me, the three variable I did you my own was aggression, delinquency, and hyperactivity. So with that, I can now see, okay, this one has a higher mean than this one, and this one has the lower mean than this. Then you can now discuss based on that. This is the discussion, attributed to that findings. Any question? Because, okay, let me look at our manual. That's what I said. I wanted to say that and that. You can. Let's go back. This. I said it before that in this one, okay, it's not on that paper. You remove this minus 0.0. So leaving only 0.704. Okay. Sometimes some people will use the highest value on the row. You understand? So, like this one now, okay, you can remove this minus 0.08, minus 0.43, minus this. So at the end of the day, you can have about 3 factors in 1, 2 factors into 1 factor here. That's what I'm saying. With this now, the textbook laboratory must be only in 1 of the 3 groups. You understand what I mean? So you now find out that the textbook, laboratory, and curriculum can be in 1. You understand? Then the laboratory can be different. You know, this is the highest here. But what is this telling us? That the first factor, you know, see, if it is XCM, this number 1 factor will now be a confirmatory factor, and it has confirmed it that although we have 3 factors, but this number 1, if you notice, it has more values than the others. But this is just exploratory, just tell you use it, that is your discretion to choose these factors that you can cluster in one of the, so in the 3 groups. What it means is that these 6 factors can be clustered into 3 major factors instead of 6. 3 major factors. But what confirmatory CFA does is to tell you that 3 factors, this is the one that confirms the others. That is the one that is evident, okay, with the statistical tools. You know, when something is confirmatory, it will give you the p-values and everything that is there. Okay. Like now, if you like 5 variables, 6 variables, okay, when you see the means there, you can now say, okay, this is one that is higher. There's an aspect they call mean ranking. Okay, you can now rank the mean in ascending or descending order. Is you understand? So with the ascending order, you can now know, okay, this one is the mean with the highest, followed by this, followed by that. It depends on what you define as your variable. It depends on what you are working on. Okay, in that mean ranking, I don't want us to go further until tomorrow when we look at the t-value. Because everything tomorrow will be on inferential statistics. So the one will be taking decision. Because that inferential statistics is what we call the major part of that is the hypothesis test. Okay, where you make decision based on what you are. So everything about tomorrow will be, so everything about today will be just descriptive statistics. Yes, so what I'm saying now, I can leave only laboratory alone. Okay. Okay. Yeah. Which one is higher? This higher than the other. No, it's not. What that means is that you have 5 variables. You know, you can define mean at different aspects. Mean can be the level of awareness. Okay, when the mean is high, then that means the awareness for that group is higher than others. You understand? When it is lower, you can say, okay, this group is lower, or that variable is lower. So it depends on what you find out as the interest. It can be the same. Okay, it can be the level. something, it can be awareness or the rest. So the remaining part of what we have to do today is we are going to how to construct different shards. So I sincerely hope that this our data can give us what we want. So every other thing we are going to do today will be on graphs. So we go here. So let's start with bar chart. Let's say simple bar chart. See, this three, even up till now, it still confuses me. These three, summarize, independent, and this. So what I do, because I'm always in a haste, I'll keep trying and error until I got it, because I don't have time to start doing again. Most times I put it down, I always forget. But it's not like, you know, in Excel, it's very easy. You just click insert or data, click bar chart, give you the example. Here, it's not easy like that. So most times I struggled with this. But easy, I think it's easy. So let's with simple bar chart. So I don't know, this is a little bit slow. Okay. I don't think it's this. This is slow. I think this is the responses. You saw what I did? Okay. Graph. This is sensitive. Bar chart. Simple. You leave it at the first one. Is it? You continue. You put the first thing there, and then you click OK. Hmm? Hmm? No. Cancel it, please. Not what we meant. Cancel. Or reset. No. Okay. Okay. If I come back again, the file, just give me this. 3. Maybe there's an issue. It's not supposed to be like this. Maybe clear this. No, and go back. Unless the system had issue, but this is how it's supposed to bring it. So this is what I did. You can put title and the rest. Then we can color it, please. We can color it. Okay, let me color it with. Got it? I can double click on any of the bar and color it. Double click on any of the bar and color it. Choose any color, white, red, blue. Yeah. The first one. Why did it appear like this, the same thing? What did you do to? No, what I did. Because it's the same thing happening there. No, be clear the output. It's the same thing that happened there. Clear the output and then go back again. Double click. Yes. Put the first one here.
Okay.
Okay. Double click it. Surprise. Wait. No, double click here. Double click any of the place.
Outside.
No, this SPSS is different. Double click here twice. It's different. Or maybe let me know if it's anyone that I've done. Have you gotten it? Has not double clicking. Okay. You can choose any color. I chose blue. You can choose red. There is no way you will break color. Double click it. Double click again. No, double click again. I'm surprised. This one also I've also brought. Okay. I'm surprised how this thing is not working. Where is the cursor? Okay. Check it. Feel the border. Feel and border. Choose any color. And so let's try it for all the other variables, please. Let's try it. Please, let's try it for other variables. Okay. In the next 10, 15 minutes, that's what we'll do. Let's try it for other variables. I want to see, we've done A1, don't do A2. Let me look at it. A3, A4, A5. Thank you. I choose different colors. Line graph. I will draw line. I will put on data. I will draw line. So let's look at why you are doing that. There is something. I can change the background to white. It's white now. You can have index line. What to do is just go ahead and, be working on it, When you learn something new like this, if it's me, I am always intoxicated if I learn something new. I won't sleep. That's what I'll be practicing until I perfect it. Okay. So there are a lot of things to do there, Insert legend is there. You start clicking all the icon. If it can't beat you, you can do it, and if it's not okay, you go back a lot of things. So let's work at it.
You want to present this chart here. It gives you a particular resolution, increasing the TERTIARY, size,
You copy it to Word and do the manipulation. You know, when you copy it to Word, you right-click the graph, and then you see figure or table properties. You can resolve it. The same thing you do for table. Copy it to Word document, and you can manipulate. You can export, or but me, I prefer copying because. Yeah? Compare means is if you want to, like now, let me give an example. Maybe you have 5 variables, 2, 3 variables. You want to look at, you have 3 variables and you want to look at the effect. You know, the mean is the effect. Maybe it's ICT awareness. You want to know, that means those that have higher mean has more ICT awareness. With that now, maybe it can be year 1, year 2, year 3, year 4. So you now compare, okay, at the end of the day, you now come as, okay, year 3, year 4 appears to have higher ICT. Then you now still give it, maybe because they have to learn it for their project. You know, you understand, it can be one of the year 1, maybe they just come in, maybe if you not, maybe the year 1 will have the least. It can be something like this. Maybe this is year 1, this is final year. Or can say, okay, maybe they are just around, they've not yet learned the process of ICT. But this one, they have been for many years. They have learned it. That's why it appears the mean is higher. Okay. Yes. Yes. Okay. So please, I just want us to, in this aspect, we'll learn it ourselves. You can manipulate the chart any way you want. There's nothing stopping us. The data is still there. So you can manipulate it, just do anything you want. Change the colors if you want, you know. Insert legend. So let me tell us some other things. You see, there are some other things to do, which you can just right-click. So this area, the best thing is for doing it yourself. You can, when you right-click, you can add title, add annotation, add text bar, add foot, show grid line, you know, transpose chart. Anything you want to do it there. You know, that's how to learn. Just, you can do anything there. Just right-click that chart. You can add title, do anything you want to do. It won't affect, the data is already there. So after, you can just delete this one. It's nothing really much there. So this is a practical section. So let me wait until we're able to perfect it well. Okay, that's nice. Okay. Eh? Just double click. Okay. It's left for it's practical. Maybe you are doing that. Maybe sometimes you can edit this. You can edit this. Okay. You can edit this. Okay, let me see now. You can edit this. Maybe let me call it frequency. Then after that, you just press enter. Okay. 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 You can edit it, can change it to frequency. Chart is good for engineering. In engineering, we show a lot of charts, a lot of drawings. Okay. I thought this is. It's line graph. I will look for, okay, do I have data of glory? I think I have data of glory. What about the scale? What about the scale? Wait. No, I say, double click it. Then, right click. You can do a lot of things there. That you can change the size when you copy it to Word. I've not imported before, so like this, my friend, say you can import it to Word document. But me, I usually copy. So when I copy it to Word document, I will reduce the size. In Word document, it will see it as a figure. You can reduce the size. You can edit the count there, change it to frequency. There are a lot of things to do. There are annotations, legend, and the rest. You just do it yourself. Don't double click anyone here. Click here. Click it here. Yes, continue. Continue, click it again. Change it to delete that and put frequency. Okay. Yes. You can put annotation, all the things there. So let's use this to learn, then we'll now come back to line graph, because I know line graph is, I think I have a very nice data for line graph. So I will try to copy a data to line graph so that open a new SPSS, data for maybe 2010 to 2020. I will plot line graph, change the colors of the line, increase the font, and then the rest. And with that, we are okay. I think this is okay. So why this line? Sometimes, like I think those in biological sciences, most of them that come for analysis, they prefer that the journal say that this line must be there. I don't know whether it's based on what they are studying. That is, the journal will require that you indicate a specific value. Sometimes they will come and say that they need it to be vertical axis. So if it's vertical axis, you click here. If it's horizontal, you click here. So I don't know why they usually, those in biological sciences, they prefer their, anytime they have bar chart like this, they will prefer this line, this grid there. So I don't know, maybe that grid can be any value. You can click on the line and change the value. For those of the engineering, this is very important, although the graph might not be as neat as MATLAB, but at least to some certain extent it tried. Because if it's MATLAB, the way it will bring the graph, it will be very nice and okay, or Mathematica or Maple. So we are coming to that. So when we are done, we go to another aspect of bar chart. But I want us to actually learn this one, very important, before we move on. So you see now, there are a lot of things to do there. You can change a lot of things. So all these things is practice make perfection. Just sit down, playing around, data. There are a lot of things to do. So most times it's holistic. For me, I say I know it all. I believe in it's holistic, especially when I maybe a of the review say that you have to replot the graph. That thing I must learn it. Even because I know if I did it, I won't have that paper accepted. I must be forced to learn that thing in order to, unless you don't want the papers. So that's why most times send your papers to where it will be peer reviewed. Most times I send my paper to some journals, the peer review will be like 4 pages. So if you just what I do for 1 month, I won't look at it. If I look at it, I'll run away. I look at it, I'll run away. I look at it, then in times I'll begin to, I can do number 1 now. If I could do 1 of what the reviewers say, I can do all. So, but the first 2 weeks, I'll just look at it close, look at it close. Sometimes, what they will write, you begin to ask yourself whether you even know what you did in the first place. So that's why I learned some of these things. Okay, I was okay, since this is what he said I should do, and I must have this paper accepted. I must learn this thing. If not, that paper is gone. So let's know if we can do multiple bar charts. Since we have, look at this. Like this, or if I could get this. So, let me know if this can go. Just don't mind me. So this is, I don't know Male, female. Okay, let me use question to. This is for clustered. Continued. Okay, let me use this so that it will make sense. B1, or let me use the one that have a lot of. Okay, no, I want the one that has school. Okay, that's why I said this data does not, it's highly skewed. You can't actually, assuming if the data is more, we can do multiple. This is what we call multiple clustered. You can change, just keep playing with those charts for bar charts now. There are a lot of things to learn there, which should be beneficial to us. So this one is for multiple or for clustered and clustered bar chart. This chart is important because if you are presenting result to maybe board members or executive, is by chart like this. That's how things like this chart. That's what we use to present so that the data will look nice. It can be when you want to assess the impact of a policy or an action. Okay, when you see bank, if you see these annual reports of banks or institutions, what you'll be seeing there is charts, pie charts, bar charts, because that's what they will easily understand, because some of them are in the field that are not mathematical. So you use bar chart to just explain to them the impact, to communicate to them the result and what it means. So, yes. Okay. Okay, put, I want the one that is, put school ownership. Yeah. Maybe put this. Yeah. Then, okay. Let's go down. Is it the same? I got. Oh, is it the same? Yes. It's something similar, yes. So, yes, you can actually, that's the beauty of it. You continue to, you get what you want. So you can change the color. The one I usually use is that line graph. We'll get there. I will look at, I think I have some data from an analysis that I did some other years. So there are some things that you even know that I might not know. that this is research class, so you explore it yourself. My own is just to open up to the basis, then you take over, and then explore from there. Because, you know, in some outlets, they will say, this is what we want. There are some journals will say only one figure. One figure, 2 tables only. So you can able to, you know, do 1 or 2 things there. Okay, let's check components to know if we can do it. This is for component. Okay. Okay. This is for component. I hope you can do it. Okay. Go to that same graph builder. Graph. You see it? Bar. This last one. Have you seen it? You can choose any 2. It will give you something like a component. Bar chart. You've gotten it? Let's choose any of the 2. Maybe choose A1 and B3. A1, B3. A1, B3. Okay. Very nice. So this is component. Go to graph. Legacy graph. Bar chart, the first one. You click the 3rd one. Then double click it. So you can choose any of the 2. So how do they look? You can change the colors. You can. I like this one. This is fine. You see some things like this, the journal publication, you'll be asking. You can color it. You can change. I can change the colors. Maybe I don't like this color. I will change this to. I'm surprised the colors have changed. Can change the colors. It looks nice. Use component. Okay. Okay, go to graph. The last one. Bar. The 3rd one. Maybe double click it. So me, I like color, especially where you want to appease, where you want it to look appealing to the reviewers. You just put the colors like that. And it makes it look colors. Yeah. So this chart is very important if you are communicating. Even in a administrative work, you use this. You need this chart to, communicate your findings to your superior on any given assignment. Okay, but for me, it's for journal publication. Sometimes, if you have figures, you don't need to replicate table. So most times, it's okay. I'll choose between. I find out that the tables are much. I use figures. You understand? You don't use figures and table the same time. It's either one. You choose figure or tables. Okay, and you explain the results the way it's supposed to be. You can. Yes, you can. That's why I guess my own is to open it up. This is a research active university. You just, pick it up and then start. You can even, do something I have never done. It's possible. The way you annotate it, the way you maybe insert legend, the way you do that. Maybe I've never even done something like that. Okay, you can change it. You can change it to frequency. Then this is NC, PGD, and laboratory. That is the response. Yes? So this is, okay, now if we can look at pie chart and, wow. No. So there are other mathematical software that can handle, especially line graph very well. But at least SPSS try to some extent. Okay. Let's check. Line should be the line. Okay. Okay, summarize, define. Okay. Oh. Cancel. So let's check to know who we first get the one for pie chart. For separate cases, define. What is line represent? This okay, this can be for individual cases. Wow. These individual cases doesn't actually make sense. So it's by group. Especially if it's a qualitative studies, like you have like 3 few value. Oh, okay, group. Wow. For group cases. So this is for group cases for male and female. Okay. Are we there? Something like this. Are we there? Are we okay with this? So the line graph should be the last we look at, because that's what we usually use, especially for engineering. Are we there now? I think let's go with the group. The first one, the first option. Then choose anyone and then okay. Choose anyone and okay. So this is the bar, the pie chart. So in this area, we look at three things: the bar, pie, maybe we'll look at bus plot, and then I want the line plot to be the last because of some statements I need to put there. So all those charts are important for maybe if it's a project or if it's a thesis. So when you are reporting the demographic variables, you can say, okay, let me include charts. So make the work looks appealing. So it's sort of table throughout. You can say, let me present, this is the male, this is the female. So there are a lot of things to do. You can look for separate cases, individual cases. Yeah, that's what I say. That's what I told him. He's used one. It's either chart or table, yes. I told him. So I want the line plots to be the last because we are taking two cases. I have some data there. I can copy it to SPSS and edit. Let's know if we can look for multiple. Yes, that's what I want to show. I think he has done it. Look at something similar like this. I think it's not for individual cases. Can extend it to. Let's try to if we can do it. Okay, we've looked at this. Let me try this. This is very sensitive. This, you know, what this individual cases is telling us is that the interpretation, I want to do it in line graph because we hardly do something like this here. It's line graph because when I had issue with line graph, it was a paper like that. I struggled until I was able to draw time series graph there. And I was able to manipulate change the colors. It was so appealing. So let me try to know if we can replicate that here. But I would prefer the line the last because we are going to look at the three cases. So SPS is not that too good for graphing. There are this they call Origin Pro. Have you heard of it? It's a software for graphing alone. I think, is it Origin Pro or I've forgotten. Origin, eh? Yes, MATLAB. MATLAB is the best. No, Mathematica for line graph. For those in mathematics, or Maple, or Octave. But this is for us here. Even the chart in SPSS is even better than R. Because this line graph, I will show you that really helped me in this line graph. So we'll okay. Hope you are following. Yes, but before I doubt if the line graph here, because I would like something. Okay, let me copy data because there's something I want to show us in line graph. Okay, let me know if I can plot this with line graph. This B total. Okay? Because line graph is usually for continuous. Simple line graph. Let me check it first. It wasn't. Could it be line graph? Made that figure. Yeah, let me bring a realistic data so that you can. Let's keep practicing pie charts. Let me until I get the data. Thank you. Until I get the data that can help us. Because it appears this one is not actually. That is what I'm saying. The data we have now cannot give us a good line plot. So let me look for. So our data can give us what I wanted. So I think I have one of my students data. Yes, something similar. Wow. One, two, three, four, five. All of them are zero decimal. Please, if you have any data at all that so let me let them down. Okay, today. Okay, let me say North Africa. Let me say South Africa. Let me say East Africa. Let me say Central Africa. Let me say West Africa. Yeah. Russia. Line. Line. Okay. Let me know if you can go. So this data is on cases of malaria. So let me know if you can. It's like a time series data from so it's like a time series data. Okay, I'm surprised how. No patient. So I want to replicate something. So the data we have cannot give us, this hanging. Maybe. I represent, no, not actually this. This is hanging. Okay, this is hanging. Okay. So if you have any data, or you can use fictitious data, because line graph, our data is 0, 1, 0, 1, so it doesn't make sense. So look, my SPSS is hanging. Okay. This is hanging. So if we use line graph, you can create X and Y, 1.2, 2.3. Okay. If not, it won't actually. Okay, let's use that B total as a line graph. Mine is hanging, so I have to. So that's one thing about SPSS. Sometimes it will. Okay, let's have a 5 minutes break. So when we come back. Yeah, he's also tired. So let me. So let's have a 5 minutes break. Mine is hanging, so I have to. So the data we have can give us good line graph, 1, 0, 1, 0, 1 to know. Line graph is usually like a regression line. You have 0.5, 1 point, maybe you see the trend going and the rest. So if you plot the line graph, it won't actually make sense. We use a continuous. Huh? So if you can see a very good data, maybe 1.1, 2 point, let's check that B total. Let's try to plot that B total. Okay, you've plotted it. This is something like I want. This is the B total. Yes, B total. Yes, the B total, because that one is on decimal. So okay. Check your solution, close the program. So don't worry, I will tell us what to do. The expressor is not responding. It looks like this. Yes. Okay. Maybe for a data that is line, because discrete data can't give us only 0, 1, 0, 1. It can't give us actually what we wanted. Yes. No, it doesn't. No. So don't worry, we'll get it right today. If it's Excel, it's easier. Okay, north, south. So let me label the data. North, North, South Africa. So this is year. Let me label it. Okay, I can. Am I still around? Yeah. Yeah. North, South Africa. Are the years, so I will reduce the decimal to 0. In all the cases, I reduce the decimal to 0. Okay? Then this is the how the data looks in XPSS from 2000 to 2017. So what I did, I go to graph, legacy graph, line graph, multiple, and individual cases. Multiple and individual cases. Then I say continue. So I put, the year, all of them have the same year, 2000 to 2017. That's why I put the year there. If it's checked, you have to check the variable. What is there will be case number. You check the variable so that this can open up to year. So when that is here, you now click OK. So let me work on this data because the way it looks, it doesn't look nice. So I can double click. Let me begin to work on the data. I can change this to white. I can change this to white, apply, ground to white. Then I'll begin to work on the individual line. Please note that. So I will start with this. North Africa. Have you seen? It's only clicking North Africa, NAC. I'll go here and increase it to 2. Okay, can I leave it this column? Okay, it's okay. You see, it has. Okay, I'll go here. Okay, let me use this last one. So it's only showing this color. I will increase this to 2. Have you seen it? This one, I will increase it to 2. Have you seen it? So that's how you do. You increase all the font size. Okay, and lastly, okay, let me label it this one black. You see? Close. So this is the graph. So you can now, the cases, if it is the cases, that is one of the things I told the lady to report. The cases of people dying in Central Africa are increasing. He said, what should be the causes? You know, I told her there is a war in Central African Republic, which is a very key country there. So it might be a contributing factor. If you notice, North Africa has a very low. East Africa is the worst. Okay? So this is this. Yes. You know, there is a war in Somalia, is it East Africa? Democratic Republic of Congo. Those countries are turbulent and, you know, because when a country is in turmoil, it affects the health sector, and the health facility there will be outstretched. Like you see in Nigeria, in northeast of the nation has been, I think I've written a paper about Boko Haram and I think 3 papers about the health implication of Boko Haram insurgency in Nigeria, how it affects. And I think there's a paper we wrote on the anemia is increasing. We did trend analysis. Malnutrition is increasing. It's just a simple analysis and they explain. That's all. No, the lead author has worked in University of Maiduguri for like 25 years. So she went there, University of Maiduguri Teaching Hospital, and brought data. And then we look at the data and perform trend analysis. And then the paper was accepted. So just small things like this. So you now go ahead and interpret. Okay? Line graph, the multiple graph. You can do a lot of things. You can change the color. You can change the line, the thickness of the line. You can even change it. I think I did something. The lines to. So it's not all the time. Okay, this black one. Okay, can come here, change it like this, apply. So it became a dotted line. There are a lot of things you can do there. You can actually shift to dotted lines. Okay, especially those in numerical, engineering or mathematics, where you are comparing approximate and the exact values. You can make one to be, I think I have a paper there that the thing looks nice. So let me, okay. I just wish I would see the economics minus missing volume. No. Most time I save a lot of, okay, maybe it's my revised manuscript. So I want to show you how it was SPSS that I used and how to distinguish 2 variables to because one of the reviewers said that it needs to see the line graph, I think, is it here? That everything is jargon onto how you use line graph. Oh. Okay, it's not here. Yes, something like this. You see, you have the software and approximate value because the results are actually the same. So this can be done with SPSS. What you need, leave this the first line as black, and then the approximate as dotted line, the same tick. You have the same result. So, any questions so far? No. Yeah, I'm done with the classes. Okay, they are still working. Okay. This is true. Okay. 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 I'm very much interested in this multiple line graph. So, I'm coming. I think let's do this, but I want to reduce the data so that it won't. I know why I'm saying something concerning this. Okay, let me remove Africa, the one that is the least. Let me remove North Africa because it affects the data negatively. Let me remove South Africa, Southern Africa. I think let's plot this. So when you are done with copying this data, let me know. I know what I'm saying. Because this multiple is very important. Most times, I don't know how, like most times we get data like this. 2000 to, no, you have the data. We can work tomorrow, we can look at correlation between both. So this should be the second data. Huh? But yesterday, I waited for like 20 minutes for some people to finish copying. I was complaining and no, no, let's copy it, please. We'll need it tomorrow, please. Okay, that's it here. Let me centralize it. When we are done copying this, I'm coming, sir. Okay, this is here. Sorry. Okay, it's okay. Within 5 minutes or 10 minutes, we are done. So that I want us to practicalize this. Sir, let's copy. Because I remember yesterday. Okay. No, to SPSS. It's okay like this. Yes, another one. Is it okay like this, sir? Huh? Okay, sir. So when we are done, I will go to the second page. No, the one only yesterday is even, you remember, the one yesterday was 15. We are patient enough. One person will call. Is it not 10 plus 6, 16? Okay. Okay. Huh? Yes, I'm coming. First one is West Africa. The second one is, okay, let me use. Okay, East. This one, WAC. Then, this one. Hope we don't have CSC members here. Yes, I'm coming. It in data view, start creating the verb. And you know, all of them, the decimal will be 0. In all cases, the decimal will be 0. In all cases, the decimal will be 0. 2000, yes, 2004. No, it continues. It's just like we have to increase the font size. Yes. If you do that, your result will be different. I have to go around and see the result. Okay, I will. Okay, 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 sir. Huh? Change the width to 8 or 8. Have you seen it? Change the width to 8 and reduce the decimal to 0. Okay. So the EAC, WAC is what we will code on the variable. It's not on the data view. On the variable view is when you put year, ESC, WSC, CSC, not on the data view. If not, it will convert everything to string. Yes. Those top now, you know, that's one of the weakness of Excel. So you put everything the same. So the ESC is when you create the variable and So what we have done, are we click? Okay, can we move forward? Yes. This. Okay, let's. Okay, ESC, WSC, CSC. So all the data correspond to the same column.
Finish filling this data.
When you come back. All right. So can. Yes. So this is 2002. Oh, I'm not even saying that. Okay, later. Our B total. Yes. So this is a real data because we obtain it from WHO website. So we have to sum all the countries under West Africa, under East Africa, under South Africa, and Central Africa. Okay. Oh. So such areas you can visit to, there are some websites, especially in economics, on GDP, unemployment, currency. You can get such data and then give it to your students to analyze as an undergraduate project. Okay. Can I shift to 2008? Okay, a little more. Further, like this. Okay, we now create a multiple, follow the process. So you save the data and tomorrow we can continue. No, follow through the year. Follow through the year. So that the year is the guiding. You see this on 2004, 2006, 7, 8, 9, 10. Okay. Okay. Are we done with 2005 so that I can shift? Okay. Can I shift? Okay, it's okay like this. Eleven is 37, I think 211, 28766, 37580.
Okay.
No, it's up to 2017. Oh. Okay, let me even state here. So, if you are working on a secondary data, because I'm talking also as an editor, one thing I will check is the currency of your data. If you are submitting paper to a journal where I'm editor or a reviewer, and the last data will be maybe 2014, automatically I will reject the paper before I won't send it to reviewers. The data will be at least 2 years from now. We are in 2020, so if it's data of 2018, it's okay. But you can see somebody, it will be analyzing from 1991 to 2011, and then it's publishing the paper in 2020. So it's not acceptable. Or when you are collecting data or your students are collecting data, the data has to be at least 2 years. All right. Okay. Have we all copied 2006? Okay. No, some people have not gotten 2008. Have everybody got 2008? Okay. Okay. You can save it. When you come back, we'll continue. So we are going for a break. Okay? Yeah, thank you. Okay, thank you. So that we'll be back here by 3 p.m. Yes. Okay, thank you so much.